Hello guys, today I'm doing corrections for my students that I'm tutoring at college. Okay, these questions are homework questions that I gave them. Uh, I did a video on speed control, and but it is written Electrotechnics N6, that video, but it is also meant for N5, guys. I forgot to write that in the description. That is also meant for N5 because this speed control as we N5 and the speed control that is in N6, it's the same thing. Yeah, well, there's no difference. Yeah, well. So I did the video on speed control calculations. Then I gave them this homework. Now I'm doing a corrections for them in this video. So you see, this is an exam question paper. This is what I deal with. I only deal with exam questions. Okay. Yeah, you can see that is 10 marks. Uh, it's 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 very easy, guys. You've seen as I've explained in that N6 Electrotechnics video. So I'm gonna do this question. This question says a 220 volts shunt motor. So we know that we know that we have to know what type of machine it is. It is a shunt motor. Okay. Draws an armature current. Notice there they are being specific that it is an armature current when running at 800 revs per minute. They say the armature circuit has a resistance of 0.77. Okay, and notice that they say armature circuit, meaning that is RAC 1, which is 0.77. The torque developed by the armature increases by 34%. Okay, that is also in the torque developed by the armature increases by 34%, and the magnetic flux decreases by 25%. Okay, calculate the speed of the shunt motor. Okay, guys, let us write our givens now. Let us write our givens. The circuit is fairly the same circuit under both conditions. Let's say, let's use, let's first write givens A2 now. We are given the supply voltage, which is 500. You're sorry, 520 volts, and we're told this is a what? A shunt motor. Okay, it draws an armature current of 60 amps. So IA1 is equals to 60 amps. Okay, while running at 800 revs per minute, that is N1. Okay, revs per minute. Then they say the armature circuit resistance. They say the armature circuit has a resistance of 0.77 RAC1, which is 0.77, okay, ohms. Then they say that load, they say the torque developed by the armature is increased by 34%. What does that mean, guys? It means that T2, okay, is T1 plus 0.34 T1. Okay, because it's T1, then you add 34% of T1. then that is T2, because they said the torque developed by the armature increases by 34%, or you can say, okay, T2 now is 134% of T1. Okay, of which is, if you divide by that by 100, T2 is, divide that by 100, sorry, 134 divided by 100, that is 1,3, sorry, T1, 1,34 T1. Either way, it's correct. Now you have interpreted the statement correct. Okay, and the magnetic flux decreases by 25%, meaning which flux 2 is, if it decreases by 25%, that means we are left with, that means, guys, we are left with 75%. That means flux 2 is 0,75 flux 1. Okay, and then now they say you must calculate the new speed. Okay, and remember now, in the second condition, they didn't tell us about anything about adding a resistance to the circuit, or either to increase or reduce the speed, as I've shown in the N6 Electrotechnics video. They didn't add anything. That means it's basically the same circuit, but the second condition contains a torque that is increased by 34%, and the flux that is reduced by 25%. So we can safely say that RAC2 is also equals to 0,77 ohms. Okay, let me draw the two circuits. I'm gonna use red for the first condition. Okay, red for the first condition. Okay. Okay, sorry. Okay, there we go. Okay. Okay, guys. Okay. This is the same circuit. This is for the first condition. For the second condition, still the same circuit. They didn't add any resistance to the armature circuit or any resistance to the field winding. Okay, which is not a chain smash. I know. Okay. Okay. We know, Tina. We have to calculate the speed. Nah? We know the formula to calculate the speed. It's E1 over E2 is equals to flux 1, sorry, N1, okay, flux 2, N2. Guys, in this case, even though it is a shunt motor, in this case, the flux changed. Yeah, the flux changed. The flux, they said the flux is decreased. Uh, the flux decreased by 25%. Okay, so we cannot say that flux 1 is equals to flux 2, as we would say in most cases when it is a shunt motor. Okay, I have explained in the flux that flux 2 is equals to 0,75 flux 1, because if it is reduced by 25%, that means we are left with 75%. And that means we are left with 75%. Okay, so what I need from this formula, I need to find I need to find this. I need to find this. This one, the flux is not a problem. The flux is not a problem, guys, because I can write flux 2 in terms of flux 1, which will make flux 1 to be cancelled out. Okay, I do have this. Okay, let me first calculate uh, E1. Okay, which is the first condition. E1 is equals to V minus I A1 RAC1. That is 520 minus what is the armature current in the first condition, that is 60 amps. That is 60 amp, guys. RAC is 0.77, and then we get E1. So let's punch that on our calculator. 520 minus 60, open bracket, 0.77. That is 473.8 V. And we have found E1. Now we have to calculate E2 now. The formula for E2 is E2 is equals to V minus IA2 RAC2. The problem now we encounter is that we don't have what? IA2, but we can find IA2 using the torque formula, T1 over T2, okay, is equals to flux 1 IA1, then flux 2 IA2. Guys, this formula you always use it to find IA2, yeah, and the reason they are they say something about the torque. The torque is the one that is going to determine the armature current of the second condition, IA2. Okay, we have T1. We expressed T2 in terms of T1, and we said it's 1,34 T1. So 1,34 T1 is equals to flux 1. Then we know that IA2 is 60 amps, okay, and we expressed flux 2 in terms of flux 1, which we said it's where is it? Yeah, there it is. We said it's flux 1. We said it's 0.75 flux 1 IA2. We see that the T1s cancels and the flux 1s cancels. Now we can find IA2, which is we cross multiply IA2, IA2 is 0.75 IA2 equals to 1,34 times 60. Then we divide by 0.75. This cancels that. You find IA2. Okay, let us punch that. 1,34 times 6 over guys, abantu abaqalayo ubukela le video ndicela baqale babukele, whether you are doing i-N5, cela niqale nibukele ividiyo le ye-speed control le ibhalwe Electrotechnics N6, yabo, please. Okay, let us calculate this current times 60 over 0.75. This current is gonna be 107.2, okay, amps, Now that we found this current, we can now calculate E2. E2 is equals to 520 minus 107,2, then 0,77. Yeah, there we go. We calculate E2 now. Okay, minus 107,2, 0,77. Then we're gonna get 437,456 volts. Now that we got E2, if we go back, we can basically determine its speed now, N2. Okay, E2, E1 is, we have calculated E1. E1 is 473,8 over, what is E2? It's 437,456. And yes. Then we have a flux 1, okay, over the first speed was 800, if I'm not mistaken, 800 revs per minute. 800 over we have 0. So we said we can express this flux in terms of flux 1, which is 0,75 flux 1 N1, okay, which is the flux cancel. Okay, oh sorry, N2, the one that we're trying to find. This is N2. So what we're gonna do, we're gonna cross multiply now. We're gonna say 473,8 times 0,75 and 2 is equals to 800 times 437,456, and then we see that we can divide by this in both sides, which is 4,7, 3,8 times 0,75. Then we get N2. So N2 is therefore equals to, let's punch that on our calculator, 800 times 437,456 over 473,8 times 0,75. That is gonna be equals to 984,845 revs per minute. Okay, then we're done with the first question. Okay, guys, the second question was saying a series wound. Okay, so I highlight that. So, sorry. A series wound motor, DC motor, rotates at 900 revs per minute when taking 84 amps at 240. Notice, guys, they didn't say armature current. But as long as they didn't describe that current as an armature current, that is a load current, that is a supply current. Please, if it's an armature current, they will tell you it's an armature current. If it takes a current of non at or from a supply, that is a load current. Okay, same goes with a shunt current or a series current. They will specify by a series field current off or a shunt field current off. Then continuing with the question, it says the armature resistance is 0,6. We are given armature resistance. not i-armature circuit resistance. That means lo armature resistance ngu-RA, ayingu-RAC. And the resistance of the field circuit is 0, okay. The resistance of the field circuit is 0.34. Calculate the value of the additional resistance. So they want the value of the additional resistance required in series with the motor to reduce the speed. Remember the circuits that I drew for you in the first video, Electrotechnics and N6. I've said that if you want to reduce the speed of a DC motor, you connect it in series with the armature, of which is this is what they did in this case, and the speed was reduced to 770 revs per minute. Then they say if the gross torque is proportional to the speed, that is also important information. Okay, the torque is proportional to the speed, the gross torque. Okay, okay, meaning in this case, since the two are proportional, torque and speed, meaning if the speed dropped, the torque also dropped. So the first thing we write down our givens. Okay, okay, it is a series wound motor. Okay, fine. We are given N1 900 revs per minute. Okay, we are given OI load 1, that is 84 amps. Then we are given UV, which is 240 volts. Then you are given ORA, okay, ORA, which is 0.46 ohms. Then the resistance of the field circuit, which is IR series, it's 0.34 ohms. Okay, they want us to calculate the resistance of the additional resistance required in series. So they want us to calculate Rx. Okay, with the motor to reduce the speed to 770 and to 770 revs per minute if the gross torque is proportional to the speed. Okay, torque is proportional to the speed. Okay, okay, guys. Now let us draw the circuit. Okay, we have first condition. Okay, here is our circuit for the first condition. Okay, sorry. Okay, yeah, sorry. Okay, okay. This is the first condition. You know, most value is the first condition, 240 volts, and Irana at N1 900 revs per minute. Okay, okay, okay. Then let us look at, we know that we have I load 1, okay, which is equals to 84 amps. Guys, if you notice here, this is a series circuit, okay? This is a series circuit. There's only one route for current to flow, okay, meaning which a current that is flowing go I series, okay, is equals to I current that is flowing or I load, and is also equals to that is current that is flowing go I armature 1, I series 1. So we can safely say that I load 1 is equals to I series 1 is equals to I armature 1, which is equals to 84 amps. Okay, let us draw the circuit for the second condition. Okay, sorry. Let us put that resistor first. Nansi le resistor bafuna siyicalculate so that the speed can be reduced from 900 revs per minute to 770 revs per minute. Then field winding. Okay. Then, okay. Sorry. Okay. The supply is still obviously 240. They didn't change it unless they tell you, okay, we changed the supply. This is RX. This is R series. Then this is RA. Okay. What we see here, guys, that the current I load 2 is still the same as OI series 2 or I armature 2, because we didn't put a diverter in the circuit. We only added that resistor in series. We didn't connect it in parallel. Okay, so there's only one route for current to flow. Okay, umahluko between circuit yokuqala and the circuit leyesibini is that RAC. On the first circuit, okay, on the first circuit, RAC is equals to, there are only two resistances, R series and R armature. Okay, which is R series plus R armature. Sorry, let us call it RAC1. Then in this case, we have RAC2, okay, is equals to RX plus R series plus R armature. Okay, meaning which, guys, eyona value endiyifuna ndiyicalculate kule question nansi. Okay, if I can find ubani R armature 2, because R series if I can find RAC2, okay, armature circuit resistance yesibini, we can actually get X by solving for or RX by solving the equation, because these two we have. Okay, but in order for us to find RAC2, we need to use this equation, V minus IA2 RAC2, of which is we have this. Okay, we don't have this, okay, so we can first find E2, okay, using the speed equation. E1 over E2 is equals to flux 1 over flux 2. Okay, then N1 over N2. Okay, let us first find E1. E1, we're gonna say E1 is sorry, let me use red. I'm gonna say E1 is equals to V minus IA1 RAC1, which is 240 minus I had shown you that OI armature 1 is the same as I load 1, okay, which is 84. Then RAC1 nansi R series plus R armature, which is R series 0.434, then R armature 0.46. Okay, then we get E1. Okay. -240 minus 84 in bracket 0.34 plus 0.46. That is gonna give us 172.8 volts. Okay, by now we have calculated ubani E1. Guys, now we can try and calculate E2, but kule formula ne, there is a catch, and of which is I've explained to you guys. I've explained to you guys that with series motor, the field current is directly proportional to the magnetic flux, unless you are told that assume that the field, the magnetic field, or assume, unless they tell you that, assume that the magnetic field is saturated. Yeah, into eba ne-magnetic field that remains constant is shunt mode. This is a series mode. So guys, I've said it, but if you are dealing with a series mode, you can, in place of bunny, in place of a field, in case of a magnetic flux, because of put in a field current. So again, your formula E1 over E2 is equals to I series 1 N1, then I series 2 N2. Okay. Of which is, guys, we don't have I series, bunny. I series or R series, bunny. Or R series, or R series 2, but we were told something about a torque. We were told that the torque is proportional to the speed, meaning if we torque reduce, if speed increase by the amount ethile, the torque will also increase by amount ethile. If it reduce amount ethile, the torque will also reduce by amount of t. What we can do is calculate the percentage torque, because it torque it drophile, ne? Let's see it drop by how many. We're gonna use we're gonna say 770 over 100. Over 900. Times 100%. Let's see. 770 over 900 times 100. That is gonna be 85.556%. Okay, meaning which, guys, we can express T2 in terms of T1, which is gonna be divided by 100, which is gonna be 0.8 0.8556. Okay, or 555, yeah, triple five six. Okay, T1. Okay, okay. Now that we have expressed T2 in terms of T1, we can say T1 over T2 is equals to flux 1, I armature 1, flux 2, I armature 2, of which is I have explained, but in place of a field strength, we put a field current. Okay, we can say it. So we can say T1 over 0.8556 T1. And it we have expressed T2 in terms of T1. Then I series I series 1, guys, ngiyambona naye ungubani ungu-84, yabo, ungu-84. Remember we said mos multiplier mos u-x into elinganayo x no-x bani bano-x squared, ana. So nalapha hence I'm gonna say 84 squared, ana. Meaning ke ngoku guys apha ndizothi sorry, apha ndizothi remember let's go back. U-I u-seconds circuit, u-I series 2 no-I amateur 2 bayathini, bayalingana, yabo. So nangu amateur 2, ane, apha besizofaka bani u-I series 2. So ndingathi I series 2 squared because u-I series 2 no-I amateur 2 are the same, of which is by product apha, ne? Okay, so this and that cancels, ne? Then we're gonna cross multiply. I series 2 is equals to I'm just solving for for R series 2 here, and okay, which is gonna be 84 squared times 0.8556. Okay, ndifumane bani or I series 2. Okay, let me punch that on the calculator. Okay, 84 squared times 0.85556. That is gonna be 77.697 amps. Okay, now we have calculated this current. Now we can calculate E2. Okay, which is gonna be, okay, E1 is 172.8 over E2, which is equals to I series 1 84, then UN1 ubani 900, then I series 2 77.697 times UN2 bani N2 770 revs per minute. Now we can cross multiply. We are just solving for E2. E2 is 172.8 times 77.697 times 770 over 84 times 900. Okay, then we get E2 as sorry, get E2 as, let's punch that, 1728 times 77, 697 times 770 over 84 times 900. That is going to give us 136,747 volts. We have calculated E2, we have calculated I armature 2, because remember, I armature 2, why am I saying we have calculated this? They are the same I series 2. Okay, now we can calculate RAC2. So let us substitute. So it's 136,747 equals to 240 minus, okay, minus 77,697 and RAC2. Okay, so that means RAC2 is equals to 136,747 minus 240, okay, divided by negative 77,697 times for RAC2. Okay, well guys, this thing is simple and in a marks. Simple and in a marks. I'm sure question A1, 10 marks. 77,697. So that's gonna be 1,329 ohms. Okay, now we can calculate ubani. We got this now. Now the question wanted this Rx. Now we can calculate Rx by substitution. 1,329 equals to Rx plus R series was 0,34 and then R armature was 0,46 plus 0,46. Therefore Rx is equals to 1 or Rx. Let me punch but these two cells transposamos. 1,329 minus 0,34 minus 0,46. Okay, sorry. Sorry. Which is gonna be 0,529 ohms. That's it with this question. Guys, this is the last question that I gave your homework. Let us read, sorry. Okay, sorry. Let us read a question again. But a 35 kilowatt, okay, 35 kilowatt, 450 volts DC shunt motor has an armature resistance of 0,42 ohms. They said armature resistance now. Okay. The full load current, the full load armature current, you see by specify by armature current at full load, which is 48 amps. But again, we'll calculate the resistance that should be inserted or connected in series with the armature circuit to obtain a 25% speed reduction. Remember, whenever you connect a resistor in series with the armature, I've said it, you are reducing the speed. Okay, if we wanted to increase the speed, we would have to connect a resistor in series with the field winding. Yeah, that is how we increase speed. Okay, bafuna resistance that should be inserted or connected in series with the armature to obtain a 25% speed reduction when the motor is developing 78%. Guys, la power bakunike pha, it's just there to trick you. It's just there to trick you really. Because guys, given power, the given power is always the output power. Okay, so your output power, which is 35 kilowatts, and it's a motor. Guys, I don't want to see this, more especially my students. If given power, output power, unless they tell you it draws a power or yeah, but they being specific about okay, input power. I don't want to see people doing saying power out is equals to V times IL. No, guys, this is wrong. Kaloku, this is a motor. The output power motor is not electrical. Please. Yabo. Le formula belongs to power in is equals to V times IL. Power in because the input power motor it's electrical. So it is safe to say V times IL when it is power in. Yabo. And we khumbule this is an electrical subject. Ayo-subject yakwa-mechanical. Yabo. As therefore, as a result, we don't have formula to calculate mechanical power. Yabo. We only manipulate to get the mechanical power. What do I mean? Equation izothi gqa ikunike efficiency, ikunike enye powers. Then you manipulate that with the efficiency formula and get the mechanical power. Please. Bathi ke it's a shunt. Sorry. It's a shunt motor. Has an armature resistance. That means Ra is equals to 0.42 ohms. The full load armature current is 48 amps. IA1 is 48 amps. Then battery will calculate the resistance that must be connected in series. Let's call it Rx. With the armature circuit to obtain a 25% speed reduction. That means N2 is equals to 75% N1. Kaloku ispeed siredusekile by 25%. That means kushiyeka bani? 75%. Please take note. When the motor is developing 78% of the rated torque, meaning T2 is equals to 0.78 T1. Okay, let us draw the two circuits. With first condition, we have something like this. Okay. Okay. It's a shunt motor. Okay, supply say to it supply say to its UV is equals to 150 volts. Okay. Okay. What is nice about this question, you are given the armature current. Yeah, 450 volts. Okay. So armature current, we are given IA1, which is IA1 is equals to 48 amps. Okay. Then let us draw the second circuit. Okay. Before I draw the second circuit, we can note that ERA, there's only a armature resistance in the armature circuit. So we can safely say OR AC1 is equals to RA. No? Then going to the second circuit, okay, they connect a resistor in series but basifuna RX with the armature circuit. Okay. Okay, 450 volts. Sorry, 450 volts. Okay, it's no RA up, ne? Guys, in this case, we can see that ORAC2 is because this and this are in series. RAC2 now changes Obango RA plus RX. So for me to find this resistor, because this question, if I this resistor, I have to find RAC2, or RAC2 belongs to this equation E2 V minus IA2 RAC2, of which is I don't have this, I don't have that. So I need to find E2. We know formula to find E2 is what? E1 over E2 is equals to flux 1 N1 flux 2 N2. Guys, when it comes to flux, you will see that supply voltage ayishintshanga. Yabo. Into ile nto yenza i-characteristic ye-shunt motor ibe ne constant field current. Yabo. Xa unofunda kwee-notes, if you go through your notes, the theory, they will tell you the field strength of a shunt motor remains constant. Okay. So we can say since it's a shunt motor, flux 1 is equals to bani or flux 2. These two cancel. So let us find E1 first. Then we find N1 or N2. But N1 or N2 is not a problem because we managed to express N2 in terms of N1. Okay. So E1 is equals to V. Sorry. E1 is equals to V minus I A1 R AC1, which is 450 minus the current armature current we between 48 na 48, then a resistance ke yangibani because kaloku RAC1 is equals to RA. It is not a problem, so which is 0.42. So kumane E1. Okay. So kumane E1. Okay. So 450 minus 48 open bracket 0.42 close bracket, that is 429.84 volts. Now we can calculate with E2. Okay, with E1 it's 429.84 over over E2 equals to, remember if flux cancelled, then speed n by n1, then we represented n2 in terms of n1, which is 0.75 n2. Sorry, n1. Then n1 bona baya cancellation. So we can find E2 cross multiply, cross multiply. Okay, because upper share no 1. Okay, 429.84 times 0.75. That is gonna be 338 volts. Now that we have found E2, sishota ngantoni? We have found this, sishota ngubani? Go IA2, we can use the torque, equation. T1 over T2 is equals to flux 1, IA1, flux 2, IA2 lo simfunayo. These cancelled most. We said that the flux in a shunt motor is the same. It would have changed if they have changed the supply voltage, because remember, E shunt field current is I shunt is equals to B over R shunt, of which is E shunt resistance is still the same. E voltage that is applied is still the same. Hence, E shunt field current is not changing. Yeah, hence we can say that loo nto yenza i-field winding, i-field strength kwi-shunt ibe the same. Yeah, because i-field current ye-shunt ayixhomekekanga kwi-current eflowa kwi-armature, ayifani nakwi-series motor, because the series motor carries the same current ne-armature. So if i-armature idrawa this amount, ne-field current iyatshintsha. That is why i-field current, i-field strength ye-series motor yona changes compared to intoni, i-shunt. Okay. So benza calculator IA2 na. So T1 over T over 0.75 T1. I have expressed T2 in terms of T1, 48 IA2. This and that T1 by cancellation. What IA2 is, we cross multiply. Okay, you find that it's 48 times 0.75, which is 36 amps, which is 36 amps. So now that we found this, now we can find RAC2. Okay, E2 is 2.38 equals to 450 minus Y, okay, 36, RAC2, therefore RAC2 is 450, sorry, 3, okay, it's 322.38 minus 450 divided by negative 36, RAC2. Okay. Then okay, let's punch that with calculator. Mm, Okay, over -36. That is gonna be 3,545 ohms. Now we can calculate Rx and using this formula. So I'm just substituting RAC2, which is 3,545 equals to ORA kanene ngubani? ORA wethu it's sorry. RA is 0,42. Okay. 0,42 plus Rx. So Rx is therefore okay. 3,545 minus 0,42. Okay, so it's gonna be 3,125 ohms. That means le resistor iminisha loo nto uba le resistor mele ibe ngu 3,125 ohms for us to get 25 speed reduction and a 70 and a torque that is 78% that of the full load. So guys, that is it with a speed control. I will never do anything with a speed control. Now I'm gonna do a matter reaction ne-commutation, then ke ngoku siyogqibezela nge-resistance status for N5. Then we're done with then ke ngoku we start i-AC theory.